The periodic table is very important in chemistry. It was created by Mendeleev. The periodic table arranges the elements according to their atomic number and reveals patterns among the elements' properties. Elements in each column share similar properties. The periodic table shows all known elements in the universe and organizes the elements by chemical properties. Atomic number. This refers to how many protons an atom of that element has. No two elements have the same number of protons. Atomic mass. Atomic mass refers to the weight of an atom. It's derived by adding the number of the protons with the number of neutrons. This cartoon is a helium atom. Valence electrons are the electrons in the outer energy level of an atom. These are the electrons that transfer or share when an atom is bonded together. The horizontal rows are called periods in a periodic table. Periods equal rows. They go from left to right. What do elements in each row have in common? The same number of electron shells. Every element in period 1, the first row, has one shell of its electrons, hydrogen and helium. All the elements in period 2 have two shells for their electrons, and it continues like this all the way down the table. So what that's saying is, in the first row with hydrogen and helium, this row right here, so it has one shell which the electrons would orbit. And period 2, which would be this row, it would have two shells the electrons would orbit. And period 3, which would be right here, would have three shells which the electrons would orbit. The columns on a periodic table are called groups or families. These groups or families have the same number of valence electrons, or electrons in the outer shell. So this column would be column 1, so it would have one valence electron. This column is a second column, so it would have two valence electrons. Going all the way to the other side, this would be group 18, and this would have 8 valence electrons. If you notice, this skips from group 2 to group 13, going from 1 valence electron to 2 valence electrons to 3 valence electrons. We jump from group 2 to group 13. Here's another style of periodic table where this would be group 1 or 1A. This would be group 2 or group 2A. And jumping over here, this would be group 13 or group 3A. Let's look at a bigger picture of this table so you can see what I'm talking about. So right here you can see that it's 1A, 2A, 3A, and so on. So those would directly correspond to valence shell electrons. Let's go over what we already know about an atom. We know that in the center there's a positively charged proton. There's a neutron that is neutral, and together these make the nucleus. The electron is on the outer part of the atom, and it follows a path that is called a shell. We said that the elements that are horizontal on the periodic table are periods, where every element in that period will have the same number of shells. Period 1 has one shell, period 2 has two shells, period 3 has three shells. We describe the groups on the periodic table as having elements that all have the same number of valence electrons, or the same number of electrons in the outermost shell. So what is a valence electron or the outermost shell? The outermost shell, or these shells, the outermost part of the atom, are called valence electrons. So when we say all of the elements in group 1 have one valence electron, that would mean that they have one electron in the outermost shell. So period 1, there's only one shell, so there would be one. For period 2, there are two shells, so there would be one electron on the outermost shell. For period 3, there would be three shells, so there would be one valence electron in the outermost shell. Going to group 2 or column 2, all the elements in this column would have two electrons in the outermost shell, or 2 electrons in the valence shell. So starting at period 2, there would be 2 shells, and the outermost shell there would be 2 valence electrons. So that would be this element right here. And moving down to period 3, there would be 3 shells. So there would be 2 electrons in the outermost shell, which would be the valence electrons. And that would be this element. The elements of a periodic table can be divided into 3 main categories: metals, nonmetals, and metalloids. Properties of metals: good conductors of heat and electricity. They're shiny. They are ductile, meaning they can be stretched into a thin wire. They're malleable, meaning they can be pounded into thin sheets. A chemical property of metal is its reaction with water, which results in corrosion. Properties of nonmetals: they're poor conductors of heat and electricity. They're not ductile or malleable. They are brittle and break easily. Nonmetals are usually dull. Many nonmetals are gases. Properties of metalloids: metalloids have properties of both metals and nonmetals. Metalloids are solids that can be shiny or dull. Metalloids conduct heat and electricity better than nonmetals, but not as good as metals. Metalloids are ductile and malleable.